Intro Algebra, Lesson 1-6A. Data is any information, facts, or numbers that describe something. So one of the questions I have is, how could you collect data? Well, there's a number of ways you could do that. You could call people on the phone and ask them questions and collect data. You could hand out a survey and have people do it. You could send out a census, have them mail it back. You could walk door to door and ask people. You could stand on street corners. There's a whole bunch of different ways that you can collect data. You could set up a marker in the street that every time it gets run over, it collects and determines how many cars drive by in a given amount of time. So there's so many different ways that we can collect data. It's basically just information. And what we do with that information is we might make some new conclusions, or we come up with new ideas, or how we're going to run our business based on that information. Now, we take data and we like to display it in different ways. And one of the ways that we will display data is with what's called a bar graph. There's two different ways you can draw the bar graph. It represents the same information, but it's one of the ways. It's not the only way to organize data, but we'll either make it so that it's vertical, so a vertical bar graph, which is pretty traditional in the sense that a lot of people are used to seeing this particular bar graph. I think it's very good for situations like buildings, comparing different objects. So if you wanted to, compare the tallest buildings in the world, a bar graph would lend itself well. But it's also good for comparing the number of pets. Say most people have a dog, followed by a cat, and then a bird. The bar graph is going to show you when you compare different items to each other. Favorite ice creams: chocolate, mint chip, Rocky Road, and vanilla is somewhere down here, non-existent because it shouldn't even be a flavor. But this is a really good use for data whenever you're comparing different items. Now, over here, a horizontal version, the exact same thing, but horizontal, we would have just tilted it. But again, it's still the same. You're still comparing, the ice creams, chocolate, mint and chip, Rocky Road, vanilla doesn't exist. It's still the same. And it's easy to tell which one of these is the biggest. Now, I have to caution you, because depending on how you use a graph, you can actually manipulate it. I have gone ahead and I have made a graph. Pull up a blank screen. I have made a graph, a bar graph of cable subscriptions. As you look at the cable subscriptions, you can't see the details very well, but down here it starts at 0 and it goes up to 4,500. The top of this graph is 3,500, the top of this graph is 3,700, and the top of this graph is 4,300. So there is an increase, and you can tell that in 1991 there are more subscriptions. But I can manipulate this data to make it seem how I want. I can change the scale. I could focus in just on the tops. I could zoom in so that my scale, instead of going from 0 to 4,500, is much smaller. And I'm going to accentuate the difference. So the exact same data, but on a different scale. Here I have it. Now it's starting at 3,000 instead of 0 and going up to 4,500. And as you can see, it still goes up, but it looks a lot more dramatic. You need to be careful. Sometimes information is manipulated to suit its circumstances. For example, let's say that I was an employee, and I could say, well, when John was in charge of the company back here in 1989, we had some increase. And we had a little bit more increase. Not much at all. Or I could say, when John was in charge, and then I took over in 1990 and 1991, you can really see how much better the company is when I was in charge. It's the exact same information, but people see what they want to see. And they're going to see that these bar graphs are not the same as these bar graphs. It's much more accentuated, even though it's the exact same info. So be aware of that as I manipulate it. It's called manipulating when you change the scales. Okay, we have another form. So again, this is not the only other form, but it's called a line graph. And it is another way to organize data, but it's especially useful when you're comparing the same item over time, the same data over time. So you get to see how it's changing compared to itself. You can certainly run more than one line graph on a paper. Here's an example of what a line graph might look like. And again, like I said, you might have something else that's out there doing its own thing, and then finishing there. There's nothing wrong with having more than one line graph on a graph, but typically a line graph works best when compared to itself. Maybe these are different months. Maybe they're different days over time, different hours, but you can see how it would change. A stock profile with a graph is going to have lots of line graphs showing you the increase or decrease of the stock. But you must be careful, because in the same way that the bar graphs can be manipulated, so too can the line graphs. So here is a graph. Go back to my blank screen. This is a graph of unemployment rates. And as you can tell, in March through August, there was an increase. It didn't look too dramatic, but there is an increase. I go from 0 up to 7 is my scale. If I want to zoom in, I now go from 5 to 7, which means I'm really only looking at the top, and as a result, it sure makes the graph look a lot more steep. If I were to stretch the bottom axes out really long, it would draw this whole graph out longer and make it look less steep. If I were to push it tighter together, it would make these look steeper because the increase would be more dramatic, it would be faster. If I scrunch this scale down even more, then it really starts to look more vertical. So I can manipulate line graphs to give them all kinds of appearances. Again, look how flat this one is. It still goes up, but it doesn't go up nearly as dramatic as this one here. Now we're coming into some political times, and you got voting coming up in 2012, and there's going to be a lot of talk about this type of thing, unemployment being a very hot topic. You know, one candidate might say, under my expertise, the unemployment did rise, but didn't rise very much. Whereas the opposing candidate might say, underneath so-and-so, the unemployment rate skyrocketed. And they would make it manipulated to make it appear what they make it suit their own opinions and how they want it to be. It's your job to look at the actual data, look at the scale, and see if they've tried to manipulate it in any way. It's not illegal, they're not lying, it's called manipulation. So you might say, well, that doesn't seem very right. It's your job to know how to interpret graphs and know what to look for here to see if you're actually getting the full picture. Now, one more example. This one again I did with the ice creams just to kind of show you how it could look. Strawberry 15, chocolate 37, Rocky Road 17, 12 for vanilla, and 19 for chocolate chip. And here's the scales. They go up by the same 10 increments, so it's not like it's scattered and going up by 10 and sometimes 8 and sometimes 30. Down here I used a different color for each one of the types of ice cream so they're easily distinguishable. Again, bar graphs work well when comparing different amounts, and you can tell exactly according to the bar graphs where each one fits. Chocolate being the best flavor obviously is going to be the highest. Vanilla being the worst flavor on the planet is going to be the lowest.